All right, folks. Good afternoon. My name is Joshua Mendoza. This is a presentation. It is for Math 32, Section 1 with Professor Suzanne, fall semester 2020. Today we're going to be covering DeMorgan's law, and hope you guys learned something. So, what is DeMorgan's law? DeMorgan's law states the complement of the union of two sets in the intersection of their complements and their complements of the intersection of two sets in the union of their complement. In theory, these laws relate to the intersection and union of sets by complements. As you can tell right here, this would be our formula, which is A union of B, which will equals to A union of B. And as you can tell in this diagram right here, you can tell this is the intersection between A and B, and then this would be the intersections of A, B, and the intersections between A and B together. So this is a example illustrating as to what I was talking about in the previous chart. As you can tell, by using DeMorgan's law, um, we complement the union is equivalent to the intersection of the complements in perspective of the A union of B, which will equals to A U U B. And for this part, we see we're talking about the left hand side, in which um, since A and B is a universal set. Um, and so, yeah. But for the right hand, we are seeing um, all the universal sets for A. For step 2, we see all the universal sets for B. And for step 3, we see all the universal sets for A and B. Therefore, we are able to determine the um, U A union of B is equals to this. And based on all the steps that we did, it proves. Therefore, moving on to a more simple problem. Now we're using negations using DeMorgan's law. So we have two statements right here. 6 plus 3 equals 9, 7 minus 6 equals 1. Um, in the previous example, we were using A and B. In this one, we're going to be using P and Q. Therefore, the solvent of it will be uh, P union of Q, which um, it will be here. And then 6 plus 3, we know that it's that equals to 9. And then 7 minus 6, we know that is 1. So, in pretty much, we now know that this statement is true, and based on the negations of it, we are able to figure that out. Okay, and why exactly, you may be wondering, this is important. Well, in my opinion, these logs are helpful in making valid inferences and proof. So just as the two examples, we were making sure that our arguments um, were um, that were true, that the statements were right. Like 6 plus 3 will equals 9. You know, that statement is true because we know that 6 plus 3 is 9. Also, in resolving deductive arguments and DeMorgan's theorem may be applied to the negation of a disjunction or the negation of a conjunction in all or parts of the formula. And that concludes my presentation in DeMorgan's laws. It was pretty quick, a bit confusing, but kind of straightforward. And some of my references were Wikipedia, Google Images, our lecture notes, and YouTube. And yeah, thank you.